Hello and welcome to OpenMind's third AMA program, Ask Me Anything. OpenMind is an open source community focused on making the world more privacy preserving by lowering the barrier to enter the private AI technologies. In this AMA interview, you'll have the opportunity to ask questions of privacy experts from OpenMind community. My name is Amel Sellami and I'll be your host. I'm from Sfax, Tunisia, and I'm an AI engineer working at a company named Ensteady. Ensteady is based in Tunis, basically. First, we are going to have three amazing people with us. Andrew, the leader of our community, he's going to talk about OpenMind a little bit and our initiative and for the initiative and all. Before carrying on with our schedule for today, which we'll be talking with Anne and Jason, we're having a tech talk and we're having Ask Me Anything questions today. So two parts. Stay tuned. But first, let's have Andrew. Hello, Andrew.
Hello, Amel. Thanks for the introduction.
Thank you.
So today I want to talk about this very special episode of Ask Me Anything, in particular because we don't just have the pleasure of being able to interview Anne, but also Jason is going to give us a wonderful tech talk talking about TensorFlow and privacy. And then additionally, in 9 different cities around the world, different meetup groups are meeting in person to attend this event and then be able to collaborate and chat with each other. So in particular, I'd like to welcome the folks in Lagos, Chennai, Washington, D.C., Edinburgh, New York, Raleigh, Barcelona, and Romania. And of course, please, if you do have questions at the event, please ask your meetup host to send those questions into the live comments so that they can get forwarded here and Amel can ask them. So thank you all for tuning into this very special Christmas episode, and I hope you enjoy it. Back to you, Amel.
Thank you, Andrew. Thank you very much for the introduction. So for our first guest, we're having Anne. So Anne Lessener, who is a fully qualified German lawyer, admitted since 2018, studied in Jena, Germany, and New Brunswick, Canada, currently focusing on advising startups and VC funds, in particular, on the implementation of the EU General Data Protection Regulation, GDPR, in particular on legal grounds for data processing, controlled processor relationships, and the rights of data subjects. During her traineeship, Anne worked for the Thuringian Data Protection Commissioner and the Institute of Law and Informatics of the University of Saarbrücken, inter alia. So welcome, Anne.
Hi, Amel. Thanks for having me.
Thank you for having us. Thank you, Anne. So, Anne, we had more than 15 questions submitted beforehand for you to answer. And in the next 30 minutes or so, we're going to try to answer as many as possible. Are you ready?
I'm ready, yeah.
Okay, great. Let's do it. So the first question is, has GDPR made a difference? If so, what have been the biggest changes?
Yeah, well, it certainly made a difference to my workload in May 2019. But what is actually, we had a data privacy guideline since 1995, and the basic principles of that haven't changed much. So from a lawyer's perspective, at first sight, not so much has changed, but I still think it had a really huge impact because of mainly 3 factors. The biggest thing is that the sanctions significantly increased. So before, I think in Germany, it was up to from 30 to 50,000 euros, depending on the severity of a data breach. And now so there are 2 different kind of sanctions, sanction catalogs, depending on the severity of your breach of the GDPR, but it could go up to 20 million euros or 4% of the yearly global revenue of a company, and that's a lot, and that deterred a lot of people. And we have seen sanctions ranging up to 200 million euros. For example, the one against British Airways, or we already like the most recent one, I think, was the one against Google with 50 million. So that is one major thing. And the other thing is that it's a regulation instead of a guideline, meaning that it applies directly to each member state without them having to implement it in national law. And that means it's now a lot more harmonized throughout all the member states. And also one big thing was that the territorial scope of data protection changed a little because now we have something called the marketplace principle, which means that even if you're outside EU territory as a data controller, you could be affected by the GDPR. And in that sense, yeah, I think a lot of things have happened. Some negative things have happened too. We have a lot more bureaucratic hurdles, a lot more documentation. As a consumer, I have to read a lot longer privacy policies because the GDPR requires controllers to include a lot more stuff in the privacy policies. And in some aspects, unfortunately, I think it hasn't made much of a difference, because in some aspects, the GDPR had a few good ideas that still, like more than 1 year after its implementation, haven't been put into practice, like the right to data portability or certifications. Those are theoretical ideas laid down in the GDPR, but honestly, the authorities haven't come very far with implementing them.
Yeah.
So yeah,
that's
the
really
overall
bad.
story. Yeah.
Yeah, we should think about it. Yeah. So another question is, what about AI models which memorize data? Are these restricted under GDPR?
Well, maybe a little disclaimer before the next questions come up. A lot of questions tonight I will need to answer with the least favorite lawyer answer, which is it depends. Because the GDPR protects privacy, and that is not an absolute right. So it's restricted by a lot. So every time you apply the GDPR, you have to weigh a lot of interests, and that means you would need to know the specific details of data processing. So it really, really depends on what the AI model does, where the controller sits. Does he sit within the European Union? What kind of data is it? Who gets access to it? What are the legal grounds? But potentially, that said, yes, if an AI model memorizes data, it could be restricted under the GDPR. If that's within the territorial scope of the GDPR, meaning that the person who uses that model has an establishment within the EU territory, or at least even if they sit outside the EU, they somehow deal with residents of the EU, and provided that it's personal data. And personal data means data to businesses. So, I mean, you could also use a neural network to process merely business data. In that case, the GDPR would not apply. But if it's about humans, and if the humans are in some way identified in the data set or identifiable, in that case, you would come into the range of the GDPR, and there's a lot of obligations would need to be observed by you. Yes.
So there are lots of restrictions when it comes to having the data. Yeah, great. So another question is, does encrypted data fall under the protections of GDPR? Does it matter who has the encryption key?
That's a really good question, actually. Again, the answer, it depends. So the GDPR is what we call technology neutral. So it doesn't prescribe any specific technological means. The reason is that technology evolves so fast that the regulators rightly said, let's not put any specific technological requirements in it, because they're going to be outdated within a few years. So what they did instead is that they say that maybe you could imagine the obligations under the GDPR like a scale, and you throw in the interests of data subjects on one hand, and then measures that you take on the other. And encryption could be one measure that lowers your obligations under the GDPR. And then if encryption is so good that it anonymizes data within the meaning of the GDPR, and that means that you cannot identify a person anymore, and no one else can. And it's either technically, like mathematically proven, or economically, like there is the faint theoretical possibility that you could decrypt it again, but no one who has the key is going to do it because it's way too much time consuming or too expensive. In that case, you would say the data are anonymized, like properly anonymized. And in that case, they are not personal data anymore. And then the GDPR wouldn't apply. And to determine the difference between like properly anonymized and that's not personal data and still personal data just reversibly encrypted, it really is important who has the encryption key. Because if you're the controller and you encrypt the data, let's say you're a company and one of your employees encrypted them and the other and remains with the key, and then the data is used by another employee, then you would still say that within that company that has both those employees, the data is not anonymized, and then you would still fall under the GDPR. So really depends. Still having the encryption key is a sure way to not be able to argue that they are properly anonymized.
Okay, yeah, great. Well, cool to hear that. Thank you for your answer, Anne. Well, another question is, does GDPR limit the access to under data by data scientists, ML researchers, to build models, gather insights? If yes, how?
Yes, it does. Again, it depends. So if the person using them falls under the territorial scope, and if it's personal data, then you fall under it. And in case your model or your research is affected by the GDPR, you have a lot of obligations. Maybe I'm just going to pick out a few because it's going to take too long to talk about that in depth. One major principle or pillar of the GDPR is that you always need legal grounds to process data. So the general idea is that it is prohibited to process personal data. That's maybe the biggest takeaway from this AMA. And if you do, you need legal grounds. And that could be a consent of that person, that could be performing a contract, that could be legal obligations from any other source. But if you are a machine learning engineer, researcher, scientist, and you process personal data, you need to sit down and see, do I have a legal ground to process these data? That's one thing. Another important thing is that the data subjects whose data sets you use for maybe training your model have information rights and other rights. They have a right maybe to object to the processing. They have a right to be informed of what you do. So you can't just take the data, leave and do whatever you want, but you would need to keep people updated, be transparent about what you do. And in that way, that's just two pillars where you as a machine learning researcher could be limited by the GDPR.
Okay, yeah, I see what you mean. Thank you. So let's start from the root. Actually, I should have asked this question before, but people are asking what is GDPR. It's not. Yeah.
Maybe we should start with that. Yeah.
Exactly.
So it's an abbreviation. It stands for the General Data Protection Regulation. General because you could also regulate data protection just for specific sectors, right? You could say, let's regulate health with those and those laws, and let's regulate processing of data in an employment relationship specifically. But the EU chose an approach where they say, let's just have a very broad, general, abstract concept of on how to process data. And well, data protection maybe is self-explanatory. I can say a few more sentences on that. And regulation is interesting because, as I said before, the European Union is not a real state, right? So it's not like Germany, which can directly enact laws, but it has different ways on making laws, and the main distinction between the laws that the European Union makes are guidelines on the one hand and regulations on the other hand. And regulations are the abstract ones that need a few more, need more legal acts by the national states, and regulations are the ones that are valid directly, like a normal national law. And that is something that is new, because before we had a guideline. And this means the EU makes the law, and it applies to me as a company or as a data subject without Germany or whatever member state having to enact any intermediary step to make it valid and effective.
Okay, good to know. Okay, thank you very much for your answer. I hope this makes it more clear for people. So another question is, does the GDPR limit the access to users by, okay, we have that on, yes, sorry. So what is needed for companies to start adopting private AI when the key relying on crafting their privacy statements such that they can use the data as is?
So the way I understand this question is that we assume there is a company and it already has some data and it already has a privacy statement, and now it wants to train maybe a neural network on them. And then the question is, what do they need to observe? So again, when you process data, you need legal grounds, and you can only process them for previously specified legitimate purposes. And if I am a company and I have gathered data, I need to observe in the first place that I have good legal grounds to do that, and that I stay within my purpose. And now if I were to extend the processing of that data, like maybe previously I just put them in analog files or something, and now I want to train machine learning models on them, I should carefully reassess whether my original legal ground still holds. Like maybe it could be that that is not, let's say my previous data are based on consent of the data subjects. So everyone who gave them to me consented to that. And that consent can only ever be valid if people are sufficiently informed of what they consent to. And if they didn't know I'm going to train neural networks on them, it could be that my consent doesn't reach as far as I needed to be for training that model. And also maybe it depends on what I want to do with that AI model. But if the AI model does something that I have not originally collected those data for, like maybe I want to do something entirely different, aggregate statistical data and sell them to customers. In that case, I would probably also be above the limits of my previous purpose. So depending on what happens, that could mean that I need to treat those data as if I had acquired them newly and need to rethink the legal grounds and the purpose and also the information obligations that I have.
About them, yeah.
So it's not that easy.
Yeah, I think it's easy with privacy preserving machine learning.
No, unfortunately not.
Yeah. So another question is from it is how to use technology, its various tools and services in privacy preserving manner. So what do you think?
That's again a very broad question. So maybe I'll start answering it with general principles as well. So the principles of the GDPR, a few of the core principles are lawfulness. That's what I said before, that you always need a legal ground to process data. Data minimization. Never process more data than you need for your purpose and only store them as long as you need. Integrity, confidentiality, don't just hand it out to third parties who have nothing to do with it. Accuracy, don't process data that are just factually wrong, and purpose limitation. Stay within the purpose. And if you use any technology, you need to observe these principles. And maybe it makes sense to use an example, because all of this is very abstract. I'm aware of that. Let's say that you are a company and you have employees and you use a human resources software to process their data, like the data on their bank accounts, where do you pay their salaries to, and maybe a few pictures of them, maybe their birth date. What do you need to do? So you use that software, you need to observe the principle of lawfulness. So you need to check, do I have legal grounds? With employees, it's easy. You have an employment agreement with them. That's one possible legal ground. But for example, if you use the photos of your employees to do marketing on the internet, then maybe in that case, definitely your contract doesn't suffice anymore. You would need their consent as like another legal ground. Data minimization. What do you do with the data when that employee has retired or has left the company? You could sit down and set default deletion deadlines where you say, okay, whenever a person has left the company, I'll delete all his pictures and I'll only store the data on his bank account as long as accounting standards require me to. Next principle, integrity and confidentiality. Of course, you should have that software or the access to those files password protected. You should have a role concept. You shouldn't let anyone within the company access that software and those files, but maybe only the head of HR. And they think about a concept which people can access it. You should probably tell your HR employees that these data are confidential, and then they just shouldn't plug in a USB stick and download it. As for accuracy, you should take care that the data are regularly checked. Maybe something changed about your employee. So as you see, a lot of
things.
And depending on the software. So as I said before, the GDPR is technology neutral, so it doesn't really depend on what kind of software you use, but you need to use it in a way that the basic principles and the rights of the data subjects are guaranteed. And maybe one other thing, a lot of times people use software as a service, like HR software. You could use that but use a software as a service provider. If you do that, you also have the obligation to select one that provides adequate data protection. So if you have read, and it is publicly known that this entity providing the software has recently repeatedly violated data protection law or has handed out, employee data for marketing purposes, you should better look for another one. And if you build the software yourself, like if you're an HR software builder, you observe these principles from the scratch, meaning that you should implement them so that, let's say, every person has a right to have their data deleted, and that right, maybe we'll come back to that later, but this right data, that is something that must be done within a month. And if you build a software that doesn't make it possible to delete something quickly and without remains, then it is obviously not technically possible to observe the GDPR with that. So that's another thing that's very important with tools and software. When you build them, that is one requirement that you should observe at the moment you're developing it.
Okay, cool. Yeah, cool. Yeah, okay. Thank you very much. But as I see, it's very broad and very huge.
It is very broad. Yeah.
Yeah, I think every company should have a lawyer for that. Yeah. Yeah.
Well,
yeah, it's very big at a certain point, because I don't know, there are lots of things that should be known. So I think it's like having a lawyer is very, very important, especially when dealing with the data of people. Yeah.
Well, the
Yeah.
GDPR has some. It has laws about when you have to appoint a data protection commissioner within your organization. So you could do that voluntarily, but in some cases you have to appoint someone who internally cares for all that and is responsible.
Yeah, exactly. Okay, thank you. So, well, there are lots of questions, but
What do we start with?
Yeah, so one of the other question is, what is the difference between GDPR and right to be forgotten?
Okay, so yeah, the GDPR is the general legal framework, general data protection regulation, a law that applies in 28 member states of the EU. The right to be forgotten is just one component of the GDPR. So the GDPR has a lot of components. One big of them is the rights that the data subjects have. So maybe data subjects are people of whom the data come. So the people who are affected by that and their right to privacy. And one of these rights is the right to be forgotten, which means, yeah, well, maybe I shouldn't go into details with that because it's a bit disputed, but it basically means that if someone processes data about me, I have a right to ask them to delete it. And not only that, I also have a right that they inform third parties if they made those data public and try to achieve that the third parties also delete them. And this right to be forgotten was already there before the GDPR, because the highest European court enacted it. And where it started from was search engines, obviously, because that's one of the basic technical tools where I might want to be forgotten, where it's very hard to be forgotten.
Yeah.
Yeah.
Exactly. Cool. So I'll finish with 2 other questions. So the first one is, has GDPR led to any follow-on legislations in other countries?
So where it definitely has led to follow up legislation is that so there's the European Union and there's also the European Economic Area, and the states that are part of the EEA without being part of the European Union are the EFTA states, like the European Free Trade Association, and that's Liechtenstein, Norway, Iceland, and Switzerland. And the former 3 ones have also enacted the GDPR. They didn't have to, but they just said, okay, let's just implement that. Switzerland is still debating because they can't really come to terms with whether they want it or not. Economically, it would make sense because they have many trade relations with the EU that it's going to be hard for them to not have the same standards. There has been the California Consumer Privacy Act, which has some concepts of the GDPR. I think it starts to be effective from 2020. We have seen similar privacy acts in Brazil and Thailand, and a few days ago, India just announced broad privacy legislation. And in all these laws, Europeans like to claim that they are inspired by the concepts of the GDPR. I'm not sure whether that's always the case or whether that is a story that Europeans like to tell themselves. Be happy to have an export bestseller. But it certainly led to an event of states enacting broad and ambitious privacy legislation. Yes.
Cool. Yeah. Okay. So here is the last question with you, Anne. So what future extensions, modifications, interpretations of GDPR have been proposed so far?
Not really many, because I mean, it's only, I think the process of enacting the GDPR took, I don't know how many years, and it had the highest number of modification requests from member states, I think, in the whole history of a legislation of the EU. So it was a lot of work to enact it the way it is. So I think they're going to leave it like this for another few years. But the GDPR has some so-called flexibility clauses that enable member states to make little twists to the legislation on a member state level. There's a lot of those modifications going on. And then also it has a lot of clauses that allow that the authorities specify these very, very abstract rules. And that is also happening a lot right now, that the European Data Protection Board puts out guidelines and best practices and a lot of material on how to deal with it. But major legislations, no. There's also one kind of sister legislation, that's the e-privacy regulation that is supposed to deal with the privacy of telecommunications data and voice over IP messenger services. And that just failed after 3 years of negotiations. So we'll see whether the EU tries to negotiate a new one. That is also privacy related, but it's not the GDPR itself.
Okay. Yeah. Thank you very much for answering all of these questions. You were amazing, and thank you very much for tuning in and being part of our AMA. Thanks you very much,
guys, and thanks, Amel.
Thank you very much. So next we'll be having Jason, who will be with us. Hello, Jason.
Hi, great to be here, Amel.
Great, cool. Thank you very much for tuning in. Now we're going to move to the second one, which will be with Jason. Now we're having a tech talk for today, which is diving into PySIFT TF. So I'll first introduce Jason, and if you have any questions, please put them in the YouTube section part for asking questions. So Jason, he works on privacy-preserving machine learning research and engineering at Dropout Labs. Although he mostly works on security and privacy of machine learning algorithms, his interests span a variety of broader topics in machine learning and mathematics. When he's not doing machine learning stuff, he's walking around New York City, traveling or grinding through a lengthy block of movies and TV series. Great. Thank you, Jason. So as you can see, we have our tech talk, so you have the floor. The floor is yours. Thank you very much.
Thank you. Yeah, so I'll be talking a bit about some of the work that I and my colleagues did on bridging TensorFlow into PySIFT. For those who are a bit newer to the community, historically PySIFT has been based around PyTorch, the deep learning framework from Facebook. However, my company Dropout Labs has worked a lot on doing similar things in TensorFlow, and there's a growing community around privacy in TensorFlow, especially with the advent of a few different libraries: TF encrypted, TF privacy, and TF federated. And we see the huge community in OpenMined, and it's largely been centered around PyTorch, and we wanted to kind of try to bridge this gap a bit, and hopefully get some collaboration going between the two by exposing some of these tools in PySIFT. So what I'll be doing today is just first going over some tutorials, how you would use PySIFT TensorFlow, and then going a little bit deeper into the code base to understand how it works and what we had to do to PySIFT to make this possible. So first, you can see here, we are in the main, let's see. Yes, the main repo. So here's the RFC that kind of started a lot of this a few months ago. It talks a lot about our motivations, why we think it's useful, and how we did it, or at least how we thought it would work initially. But I'll first step into the tutorial so you can see how it works. So far what we've done is just kind of build the basic tools of PySift into this repository. So it is a little bit confusing, the directory structure. This is a separate directory from PySift itself. But we'll talk a little bit as well about how it interfaces. So you can go through this tutorial yourself, but I'll just run through the code briefly.
Okay.
This does require TensorFlow 2.0, which means that we'll be doing this all in eager mode. I think that's a big benefit of TensorFlow 2.0 and what prevented us from doing any really strong TensorFlow stuff in PySift for a long time. So the two things that you actually interact with as a user are just the normal TensorFlow package and the normal PySift package. So this PySift TF repo is actually somewhat in the background. It needs to be installed, but you don't actually interact with it in your code. And so you can see just this kind of normal PySift stuff, but instead of instantiating what we normally do here, which is torch hook, we just replace that with TensorFlow hook, kind of the same way. And you can see some basic stuff. If you just create a TensorFlow tensor, you can just see it still works. But because we're passing TensorFlow into this TensorFlow hook, we're actually going to be modifying the behavior of some of the functionality that comes out of TensorFlow. So as you can see, you can do some basic things. You can create tensors. You can add them together. Now this tensor is on my machine. There's nothing new here. This is normal TensorFlow code. But it gets a little bit different once we start sending things around a network. So primarily, PySift currently, or PySift TensorFlow currently, is focused on the primitives of some of the privacy techniques. More specifically, we want to enable certain use cases like remote execution and federated learning, and eventually encrypted computation. And these all have this prerequisite of being able to work with data that's not on your machine as a data scientist. So a lot of the tutorials that we have so far are just focusing on this idea. So initially, what we would do here is just instantiate this virtual worker. This is a representation on my machine of another worker or another computer on the network, hopefully named Bob here. So we can create tensors, and then what we can do now, the extra functionality that we've loaded on top of TensorFlow is to send tensors around the network and to do specific things once they're on those machines, especially to do the normal computation we'd like to do, but on the other machine in a secure way. And so you do that by calling the normal PySift send operation, and then you can see very much that these objects are now on that machine. When you then add those objects together, you receive a result, which is actually just a pointer to the result on Bob's machine. Now this is important because we can't actually see the data unless we inspect it on Bob's machine. The result of the addition here is this tensor here, but that's hidden from my view as the data scientist. And this is kind of the core, but what needs to be true in order to be able to actually preserve the privacy of any data. Now, so some details here. This is very similar to the talk or to the tutorial that exists in PyTorch currently. We're just replacing a lot of that with TensorFlow code. You can see kind of some metadata about the tensor. This is a worker ID, so it identifies me to other people on the network. This is the ID for Bob, who is also another worker who needs to identify themselves. And so with any piece of data in the system, with any tensor, you can identify its location. In this case, we can get our representation of Bob in memory with the location attribute. And you can see that that's these two objects are identical. So another thing so workers themselves don't just have IDs. The actual tensors themselves have IDs because we want to identify where each piece of data is. And this internally is what allows PySift to keep track of all of this stuff. If my PySwift instance did not know that this X tensor was at a certain machine, it would not be able to send commands to it through the PySwift protocol. And so there's a number of attributes like that allow PySwift to quickly send messages where they need to go in order for computations to happen. And so if you ever want to reference yourself as a kind of a person or a worker on this network, you can find that in the sif.localWorker attribute. This is what actually does a lot of the communication from my machine to other workers on the network. But it's a little bit of an implementation detail that you really only need to know about if you're working within the code base. But it is helpful to know it's there.
Yeah.
And there's this difference between the pointer, which is the thing that I have in memory on my computer, versus the data that it's pointing to, which is on Bob's machine. So once we do these things, we can call get and receive the data back. When we call get on these pointers, we get the actual data again. So there's a number of things you can do. This is just a simple addition. That's an example of an add. You can see we do TensorFlow functions. So we've hooked all of the main TensorFlow functions that you could have. These are like the most common operations you'd see in TensorFlow, the low-level operations. And then we can even do the same thing for variables and do some manual differentiation. Currently, as a work in progress, we're hoping to get automatic differentiation in there through the use of TF gradient tape, which is how you would do this in TensorFlow 2.0. But that there is an open issue about that. So perhaps more exciting is the ability to actually train models with this. This is a notebook put together by my colleague Jan Dupies, who did a lot of the work with me, as well as Ben DeCoste, to put this stuff together. And so you can see that like those are the basic building blocks of actually training machine learning models in a privacy-preserving way with TensorFlow through PySwift. Here we train a model on the classic evidence data set, and we show that you can use basically all of the higher level Keras abstractions. You can use them in PySwift kind of normally. In particular, you can have these sequential models, which people who have used Keras before will be very familiar with. These are like kind of the most basic kind of model that you can build. As long as it's a series of layers in sequence, then you can just list the layers and it'll create a model for you. And you can pass all of your favorite deep learning tools like Atom and your loss functions for whatever your task is. And what you're going to do is you're going to send the model wherever the data is. In this case, we've sent it to a worker named Bob again. And so once we have that pointer to the model, we can just call fit like normal. All the normal Keras API is included. And so we can train the data, or train this model on the data remotely. And you can then see that the actually goes up and things like that. I won't run this because I'd encourage you to go run it yourself because it's good to, I think, get in the code and see how it works on your machine. So if your model doesn't fit into this sequential paradigm, it is a little bit limiting. If it's just a number of layers in a row, that's one thing, but with the functional or subclass API in Keras, you can do kind of the full extent of models that you would like to do in, for example, PyTorch. The subclassing API is very similar to the one in PyTorch. Instead of forward, you have call, and instead of nn.module, you have tf Keras models, but it works essentially the same way. And we use TensorFlow's serialization under the hood to do it very similarly. And so we do the same exact training with that custom model, and it works out just fine. So yeah, if there are no questions at all, I will continue with kind of exploring the code base and seeing what we had to do to get this to work. But at any
Yeah.
point, if there are questions, whether it's about the code or just general privacy and privacy-preserving machine learning, definitely let me know. I'd love to talk about it.
Yeah. Yeah, please put your questions in the YouTube section, because Jason will be answering them after he carries on with his tech talk. So even if you're hosting a meetup or you're having questions, please let people know that please let your hosters know that we can answer the questions after Jason having this the tech talk. Thank you. Yeah.
Thanks, Emil. So a little bit of the motivation behind how this works. Originally, PyTorch or PySift was built around PyTorch, so we had to do kind of a lot of heavy lifting to abstract a lot of that code away from the core PySift protocol. And so you can see kind of our proposal for doing that here. We have a number of core PySift internals that maybe a lot of users wouldn't be familiar with, or at least explicitly familiar with. A good example is Saturday, which is responsible for sending messages around between the different workers, and also compiling the code that we're running in these notebooks into those messages so they can be translated by workers on the other side. You have hooks. This is what actually allows you to run PyTorch or TensorFlow specific code in a way that that seems natural. That doesn't feel like you're using like a new function. As an example, we're using TensorFlow objects here. We're using TensorFlow functions, and we're able to execute those on other machines, largely because the hooks translate my Python code into something that Saturday can recognize and then compile and serialize into a message that gets sent across to the other worker. And then we have native tensors. This is kind of an important requirement for dealing with the custom functionality in PySift. Obviously, we don't just want to do remote execution on normal machine learning data or models. We also want to do custom things like federated learning, differential privacy, and secure computation. And so PySift has what's called a tensor chain that allows us to do that. If you're interested in that, you can see the original PySift paper that we published last year at NeurIPS. It goes into detail about how this tensor chain works and how it enables these different technologies. It is a little bit out of date, but I think the general concept is still the same there. So if you're just kind of getting into the code base, this is the main PySift folder, the zip folder, which is where most of the code of PySift actually lives. The main difference that you'll see after we've implemented this RFC are these two folders. We have a frameworks folder now, which is where the framework specific code should live. And then we also have a generic folder, which is where the core PySift protocol exists, other than Saturday, which is its own folder. And so when you go into this generic, this folder, there's a subfolder called frameworks, and this is where the kind of general stuff has been moved. So there's a number of things that you have to satisfy as in order to actually work with PySift now as a new framework. This could be extended past TensorFlow to other frameworks as well, so it could be interesting for people trying to implement new frameworks like Spark or NumPy or something like that. And you can see that. Let's see, you can see that these folders in the PySift TensorFlow repo are actually mimicking what you would see in this generic framework section. That's because for each of the things in here, for example, the framework hook, this generic framework hook, there is also a PySift TensorFlow specific version of it. this TensorFlow hook, and you can see it actually inherits directly from that class. And so there's a number of other generic attributes like that. For example, there's framework attributes in the original. Where would it be? Here, there's a framework attributes class. These are things that allow us to do that hooking, which allows us to run that custom functionality on the native TensorFlow functions. And this is kind of the core stuff that allows this to work. Anyways, I won't go too much further. There's a lot here. I could talk about it, but I think some of the interesting things for people who are interested in this, as far as next steps, would be to check out some of the things that we have planned. So we have some immediate next steps, some kind of medium-term ideas, and then some long-term goals as well that we'd really like the community to get involved with to make this actually come to fruition.
Okay, cool. So can I ask you a question? I have a question from Alan. So the question is, will this TensorFlow integration ever be available as part of the core PySift as it is the case with PyTorch?
Yeah, so currently this is available in core PySift. If you instead of installing PySift, let's see, kind of the normal way, which is I'll go to the README. So this is the recommended default. This installs the PyTorch backend as well as the TF encrypted one to be in line with the SD course, so that people have an easy time doing that. But you can actually pass a different term to this. In particular, you can install it with SIF TensorFlow, and that will expose this work in the core PySift protocol, or in your version of PySift on your computer. And that will prevent you from using PyTorch, but it will allow you to use TensorFlow instead. So one of the issues that I mentioned, one of the short-term issues, is to be able to do multiple frameworks within the same code. So ideally, we'd like to install both PySift or PyTorch and TensorFlow side by side. For example, if you're a worker hosting data, you don't want to have to run specific servers just for PyTorch or TensorFlow. You'd like to run a single server that's able to do both. And so there's an existing issue. I think it might be in the PySift, the main PySift code base. It's around multi-framework management. Well, hopefully, maybe I'll throw it in Team PySift after this. But it's the idea being that we'd like to be able to, in the code, switch between frameworks a little bit more quickly, and it's actually not too far off from being true.
Hopefully.
Yeah. I think so. So these are kind of some of the short-term kinks that we want to work out that we'd love to accept contributions for. This is a really great place to start if you want to do that. There are a number of good first issues labeled here in the PySift TensorFlow repository that are very specific to TensorFlow code. A few that I would recommend are this, which is getting kind of normal addition, multiplication, subtraction, etc., to work with multi-pointer tensors. I think there's some good work that was started there from George, but hopefully we can get that fixed for the entirety of arithmetic. That would enable this other one right here, federated learning, user story, for example, a tutorial in that examples folder to actually to be closed, so that someone could write that tutorial, similar to how it exists in the original PySift repository. So these are some good places to start, as well as maybe this one. This one allows for dropout layers to be added in custom models. Right, currently you can use them in sequential models, but there was a slight bug where it wasn't working in the custom model. So we think these are some good places to start to get into the code base and see how it works.
Cool.
Another good one would be to raise the test coverage, because we have tests, but they don't completely cover the library as they do in PySift.
Okay.
And so then that's like the short term. I think a medium term one might be to train a Keras model in PySift using the differentially private optimizers available in TensorFlow Privacy. TensorFlow Privacy is the differential privacy library from Google, from TensorFlow. And they have a number of off-the-shelf optimizers that you can just drop in to make your machine learning model training differentially private. And that would be a great thing to have. Currently, there's an issue with serializing them. And so that might be a little bit more of an advanced use case, but I think it would be a really great demo for someone to contribute.
Cool.
And then I think lastly, the longer term goals and issues, which we haven't exactly opened up here, but there's some work, some existing work in this repository. It's in the TF encrypted RFCs repository because we are definitely interested in bringing TF encrypted to PySift in a much more expansive way, a much more well integrated and comprehensive way than was in the original Udacity course. And we'd also like to do that in concert with TensorFlow Federated. So as mentioned before, the TensorFlow Federated library is another federated learning library from Google. There's a lot of best practices that they've learned from a lot of from their research. They were the kind of original pioneers of a lot of this. And so a lot of that stuff is in that code. And I think we would definitely like to integrate the two of them, maybe to run TensorFlow Federated on PySift with PySift workers, that kind of thing. And so TF encrypted is currently in the progress of integrating with TensorFlow Federated, and we'd also really like to see TF encrypted and TensorFlow Federated available in this PySift TensorFlow repository as well, because there's really no reason that we shouldn't be able to do both.
Yeah.
With PySift. So that's kind of the extent of what I have specific to PySift TensorFlow. If there are any other questions, though, I'm happy to.
Yeah. So we have other two questions for now, but one question is from Amber. So if people want to join development, where should they start?
Oh yeah, I think this issues board is a really great place to start. Also, if you go to I guess the main, where is it? Should I close some of these? Yeah, the main PySift repository. And really, anything that I've opened up in PySift is probably related to this recently. Well, I guess there's some things missing, but yeah. So any of these first issues in
could be a good start.
Yeah, these good first issues in PySift TensorFlow would be great.
Yeah.
And then just reaching out in Slack, talking with the team would be great as next steps because I think we have a lot of ideas and we'd really like to get people involved if possible and to start a conversation there.
Yeah, cool, great. So another question is from Kritika. How do you evaluate your model using metrics such as accuracy in the commercial private federated learning setup? That's a cool question.
Yeah, that's a really good question. So I guess it depends on. It depends, right? Usually we use a validation set to evaluate a model so that we're not kind of double dipping on our training data. If we're optimizing the model's performance on the training data, of course it'll be good. We really want to see how that model generalizes, and especially with differential privacy, there could be some complications there, right? Differential privacy is notoriously hard to get right when training a model.
Yeah.
In order to fine tune it, you really have to work with the hyperparameters to balance the amount of privacy you get with the actual utility of the model. In this case, accuracy would be a measure of that utility. And so you really need a strong validation set that really represents the data that you'll see in order to evaluate that. Now, who owns this validation set? Is it private itself? Is another excellent question. In a federated learning sense, maybe the person training the model has collected their own validation set and they don't want to use it for training because it's not big enough, but through federated learning, they can actually get access to enough data to actually train the model. So then they use their data as a way to monitor the performance of the model. The other thing there is that you can also use this to kind of validate the trade-off between privacy and accuracy that you're getting, which is kind of a very specific problem when you're using differential privacy. That this is not normally something that we do in training a machine learning model, even in federated learning, unless you're using differential privacy. But there's some excellent work around this from Google recently that hopefully I'll share in the channel after this.
Yeah, please do.
Mm-hmm.
Cool. Thank you. So I think we've finished with the part from the tech talk. So we'll have Andrew and Anne for our closing word. So yeah, Andrew, Anne, if you have anything to say for the people that are waiting for us, that would be great.
Well, I want to greet my grandma in case she's watching. And yeah, thanks for listening.
Yeah, thank you for being with us today. Thank you. Andrew, do you have anything to say to people? You're muted, Andrew. Sorry
about that. Yeah, so of course, thank you so much to Anne and Jason for joining us today. I think it's really useful content in particular. So we were talking about in the comments section there, and that basically we kind of get to work on privacy in no small part to GDPR making it important in society, and like a lot of really sort of people in positions of influence have really changed their perspective on their own needs for privacy technology thanks to this law. And so I think for our community to learn a lot more about the details of what it is and how it works and the finer aspects of it is just really important. So thank you very much for coming today. And then Jason, of course, in building our privacy technologies, it's really important that we can see privacy in all the data science tools and machine learning tools that people like to use. So thank you for giving such a great tutorial, not only on how the integrations with TensorFlow can be used, but also the overview of the code base and how development is happening, because I think that people getting involved in development is one of the most important things that we can do. So, and of course, Amel, thank you so much for hosting us today, which is great. And to everyone who has been meeting in person, I guess around the world, if not around, I guess the parts of the world that are awake right now. But yeah, so thank you for everyone who organized local meetups and for staying tuned and asking great questions. So yeah, back to you.
Thank you very much, everyone. That was all for us today. Hope we have you very shortly next year, hopefully. So see you around and ask questions and be part of our community. Thank you very much. Bye.